Alright, so in this video, I'm going to be solving the problem 5 over 2 to the power of 2 over 5. So, what many people who are watching this video are used to is solving exponents with whole numbers. So let's say we have 2 to the power 4. This is simple. It's 16. And 3 to the power of 3, 27. So these are exponents with whole numbers because you know how many times to multiply the base by itself with. So 2 to the power 4 is the same thing as 2 times 2 times 2 times 2. And same thing with 3 to the power of 3, it's 3 times 3 times 3. But now for this problem, we have a fraction. So how are we even going to go about this? Well, I'm going to first start by rewriting this as 5 over 2 to the power of 2 times 1 over 5. So I rewrote 2 over 5 as 2 times 1 over 5. Now from here, I can use the property a to the power of m times n is equal to a to the power of m to the power of n. So 5 over 2 to the power of 2 times 1 over 5 turns into 5 over 2 to the power of 2 to the power of 1 over 5. Now, if I have something in the form a over b to the power of m, this is the same thing as a to the power of m over b to the power of n. So 5 over 2 to the power of 2 turns into 5 squared over 2 squared to the power of 1 over 5. So now we can just simplify this a little bit. 5 squared is 25, and 2 squared is 4. So I have 25 over 4 to the power of 1 over 5. Now, what I'm going to do is rewrite this as 25 over 4 to the power of 1 over 5 times 4 to the power of 4 over 5 over 4 to the power of 4 over 5. And 4 to the power of 4 over 5 over 4 to the power of 4 over 5 is just 1. And this is basically just like multiplying this by 1, which doesn't change anything. Now, again, this can distribute. So I get 25 to the power of 1 over 5 over 4 to the power of 1 over 5 times 4 to the power of 4 over 5 over 4 to the power of 4 over 5. So now at the bottom here, the reason we even multiplied this with 4 to the power of 4 over 5 over 4 to the power of 4 over 5 was so we can make the denominator a whole number. So if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So because these two have the same bases, their exponents simply add up. And 1 over 5 plus 4 over 5 is simply 1. So I get 25 to the power of 1 over 5 times 4 to the power of 4 over 5 all over 4 to the power of 1 over 5 plus 4 over 5, which is just equal to 25 to the power of 1 over 5 times 4 to the power of 4 over 5 over 4 to the power of 1. Now from here, 4 to the power of 4 over 5 is the same thing as 2 squared to the power of 4 over 5. And these two multiply. So this turns into 2 to the power of 8 over 5. So I get 25 to the power of 1 over 5 times 2 to the power of 8 over 5 over 4, I'm going to rewrite as 2 times 2. And now I'm going to separate this to 25 to the power of 1 over 5 over 2 times 2 to the power of 8 over 5 over 2. Now another property of exponents is that if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of 8 over 5 over 2, which is the same thing as 2 to the power of 1, is equal to two to the power of 8 over 5 minus 1. And that's the same thing as 2 to the power of 3 over 5. Now I can rewrite 2 to the power of 3 over 5 as 2 to the power of 3 times 1 over 5, which is the same thing as 2 to the power of 3 to the power of 1 over 5, which is equal to eight to the power of 1 over 5. Now notice how these two have the same exponents. So I'm able to multiply them now. So now I get 25 times 8 to the power of 1 over 5 all over 2. And 25 times 8 is equal to 280. So I get 280 to the power of 1 over 5 over 2, which I can rewrite, because if I have something in the form a to the power of 1 over n, this is the same thing as the nth root of a. So I can rewrite that as the fifth root of 280 over 2. So this is my final answer.